Alright guys, welcome to 10.4. On this one we are first focusing on a rule for an inscribed angle. So again, much more algebra to go along with rules like this. I want to first remind you of the difference between an inscribed angle and a central angle. So remember, a central angle would look like this. Right? The vertex of that angle actually goes to the center of the circle. An inscribed angle is one where the vertex is on the circle. So this would be a central angle, and this would be an inscribed angle. And they are different rules. With the central angle, we know that a central angle is equal to its intercepted arc. Right? So if this is the angle, this would be what we call its intercepted arc. It goes from that point to that point. And they're equal if it's a central angle. So if that was, say, 40 degrees, then this arc would also be 40 degrees. The inscribed angle, which would look like this, where you're putting the vertex on the circle, not on the center, but on the circle, the rule for that one is that the angle is half of its arc. The angle is half of its arc. So as you look at this one right here, I know that this angle is half of whatever this would be. So the way I like to write that rule is like this. So you can say that the angle is half of its arc, but you can also reword that and say that the arc is twice the size of the angle. And I kind of like saying it that way as well. So because it's good to look at it both ways. So the arc is twice the size of its angle. All right. So here's an example they gave us. So they're saying, okay, if you were to look at this circle right here, circle G, right? G is the middle. The measure of DF is 90. So if DF is 90, well, what would that make its inscribed angle, right? So they're giving us what we call the intercepted arc. Right here is 90 degrees. What would that make the inscribed angle? Right? We know by this rule that we just discussed it would have to be half, right? So if the arc is 90, then half of 90 would be 45 degrees, which would be the angle that we see right here. And so we can, of course, go the other way with that. They could have told us that this was 45, and we could have said, okay, well then let's double that and get 90 for the arc. So let's try a couple of these for practice. All right, for this first one, it says, what is the measure of arc AC? Guys, remember when you see the little m, that means measure, that means they want degrees. Okay, so what's the measure of arc AC? So they're asking us for this one right here. So remember the rule that we just discussed up above. We said that the arc is twice the size of its inscribed angle. Okay, so if the angle is 36, twice the size of that would be 72 degrees. So AC we can see is 72 degrees. All right, let's go over to the next one. Measure of angle N. So now we're going the other way with it. N is the inscribed angle. Its arc is 62, so we know that the angle is half of its intercepted arc. So if KL is 62 degrees, that would make this guy half of that, so 31 degrees. All right, so if you look at this one, the measure of arc QSR. Guys, notice on this one they use 3 letters for this arc. There's a reason for that. We talked about in section 2, 10.2. So whenever they use 2 letters, they're describing a minor arc, something that is smaller than 180 degrees. Anytime you see 3 letters, they're describing a major arc, something that's bigger than 180. Okay, so that's why as you look at this, they didn't just call this QR, right? From here to here, they didn't call that QR, because if they would have said that, they actually would have been referring to that arc right there. So instead, to make it clear, they used 3 letters so that we could see it's definitely the major arc that goes from Q to S to R. So they're talking about this major arc right there, right? So we can see on this one that the angle, its inscribed angle, is 113 degrees. We know that its intercepted arc from Q to R would be double that. So if I double 113, I'm looking at 226 for the intercepted arc. All right, let's go down to these guys right here. A little more fun with algebra. Guys, this is really an extension of the rule that we just talked about. Okay, and so go with me on this here for just a second. If you guys can look at this inscribed angle. So look at VTU. So you guys see that inscribed angle right there? Do you notice the arc of that is UV? So keep that in mind for just a minute. Well, look at this angle as well. The one that goes from U to W to V. Well, do you see how the intercepted arc for UWV is also UV? Which means this angle and this angle share the same intercepted arc. Well, if they share the same intercepted arc, that's only possible if those two angles are equal to each other, right? Because they both stem from the same arc. So that must mean that this angle is congruent to this angle. Okay, so it's just kind of an extension of the rule that we've just been looking at. So if they share the same intersected arc, then they must be the same angle. Okay, so that tells me that 3x plus 4 must be equal to 2x plus 9. So if we solve that, subtract 2x from both sides, and subtract 4 from both sides, we now know that x is 5. Okay, what is it that they're looking for? They want us to figure out the measure of angle U, which would be this guy right here. They also want us to figure out the measure of angle T. So let's look at that one for a minute. We know that T is 3x plus 4. Well, we just figured out that x is 5. So what is 3 times 5 plus 4? So 15 plus 4 would tell us that angle T is 19 degrees. So that gives us that information right there. Now they want us to figure out what is the measure of angle U. What's the measure of angle U? Well, the same rule that I gave you here would also apply to this guy and this guy. Right? If you look at both of those inscribed angle, they both share the same intercepted arc. WT is the arc for this angle. WT is also the arc of that angle. So if they have the same intercepted arc, they have to be the same angle. So I know that U is equal to V. If V is 30, that means U is also 30. All right, let's apply that same rule over here. So if you want to pause and work ahead of me on this one, this is a great one for you to practice. So we need to come up with the measure of angle A and the measure of angle C. Again, this goes back to the exact same rule that we just talked about. If you look at angle B, look at where angle B goes. It goes to arc AD, right? Arc AD. Well, look at angle C. Angle C, if you extend it, also goes to arc AD. So if they share the same intercepted arc, then they must be the same angle as each other. So I know that 6x minus 3 must equal 7x minus 11. So there's our equation. Now we can go ahead and solve for x. Subtract 6x from both sides. Add that 11 over. So we now know that x is 8. That's not what they were asking for, though, so read carefully what they are looking for. What is the measure of angle A? We'll get that one in a second. What's the measure of angle C? So here's C. We now know that x is 8. So 7 times 8 minus 11. So 56 minus 11 would give us 45. So there's the measure of angle C. Look at these guys. Similar deal, right? If you trace A to his intercepted arc, A goes to arc BC. If you look at D, D also extends to arc BC. They both go to the same intercepted arc, which must mean they are the same angle. So that then tells me that 6y minus 2 is equal to 5y plus 8. So that would be the setup for that one. Subtract 5y from both sides. And that would put you here. add 2 to both sides. We now know that y is 10. So if y is 10, what is the measure of angle A? Here's A. So in other words, 6 times 10 minus 2. So 60 minus 2 would give us 58 for angle A. All right, let me go to backside on this one. All right, inscribed polygons. Let me give you one more rule here. A lot of rules for circles. Here's a rule. If a quadrilateral, so remember a quadrilateral, think of quad as a 4-sided shape. If a 4-sided shape is inscribed in a circle, here's what that would look like. So if you look at A, B, C, D, that is a 4-sided shape that is inscribed inside of that circle. So here's the rule. Opposite angles are supplementary. Opposite angles are supplementary. So that means that angle A and angle C add to 180 degrees. It also means that angle B and angle D add to 180 degrees. So they spelled that out for you right here. So here's the rule. So remember that opposite angles are supplementary in those cases. Let me give you one more rule, and then we're going to start going through some examples. If you look at this one, an inscribed angle of a triangle intercepts a diameter or a semicircle if and only if the angle is a right angle. Let me give you a diagram for that, because they didn't provide one, so we're going to make our own here. My circles are ugly. Just go with me on this. All right, so here's our circle. So if we have a triangle that just so happens to be a right triangle, I'm going to try to draw this as best as I can to make it look like a right angle. Okay, so it looks something like this. So what they're saying is, whenever you see the phrase if and only if, remember what they're trying to tell you is, this is a rule that works backwards and forwards. So here's what they're trying to tell you. If you have a right triangle, so if I know that this is a right angle, then the only way for that to be a right triangle is if one of the sides of that triangle is the diameter of that circle. So the only way to draw a right triangle inside of a circle is if you use the diameter of the circle. So the converse to that, and why they say if and only if, is you can read it backwards too. If we were to say if a triangle uses the diameter of the circle as one of its sides, then you know that this has to be a right angle. Okay, so we can do that either way. And we'll get some practice with those down below. Let me just talk you through this example that they provided for us. It's really a link back to one of our previous rules that came up on this one. So here's obviously the diagram. The information that they gave us was that these two arcs are congruent. So one of the rules that we looked at previously is that if these two arcs are congruent, remember that it means that these two chords are congruent. So that must mean that this is equal to this. Here's why they're telling you that. So for this triangle, the information that they gave us is that just this information right here. Okay, the 3x plus 5 degrees, it's really hard to tell with the way they put it in here, but that's supposed to be for angle L. Okay, so they're telling you that angle L is 3x plus 5 degrees. They're telling you that angle K is 5x plus 5 degrees. So here's what we're supposed to take away from this. They're actually trying to link this idea back to something from our first semester when we talked about isosceles triangles. So here's what we learned about isosceles triangles, was that if these two sides are equal, then these two angles are equal. So that was our isosceles triangle theorem. So if that's 3x plus 5 degrees, that means that angle M is also 3x plus 5 degrees. So we've now identified an expression for all three angles of a triangle. Here's something else we learned first semester. All three angles of a triangle add to 180, right? Triangle sum theorem. So if we look at that, we can now say that the three expressions for the three angles of that triangle add up to 180. Use some basic algebra to solve from there. Okay, so that was just sort of another example. I just wanted you to see that because there's a lot of ideas going through they're trying to draw us back to. So they're trying to make a big connection on a lot of our prior knowledge to what we're seeing within these circles. So let's talk about the rules that we saw up above. Here was sort of the upper rule that they gave us. So look at this triangle. Guys, you notice how on this triangle that one of the sides of that triangle is the diameter of that circle, WX. Well, if WX is the diameter, then that must automatically mean that Y is a right angle. Okay, so remember we said the only way for a triangle to be inscribed in a circle using the diameter is if it's a right triangle. Okay, so that was the rule that we saw up above. So how do we find X and how do we find angle W? Well, remember we know that the three angles of a triangle add to 180. So I know that this plus this add to 180. So let me just lay all that out. So we know that x plus 12 plus 90 is 180. So let's use some basic algebra to solve from there. Combine like terms. So 2x plus 102 is 180. Subtract 102 from both sides. Tells you that 2x is 78. Divide both sides by 2. And 39. Alright, so first thing they asked for was solve for x. We just figured out that it's 39 degrees. Sorry, just 39. Actually, it is 39 degrees if you look at that angle. So what now is the measure of angle W? Well, W is x plus 12. So if we take our 39 and add 12 to that, then 51 is the measure of angle W. So this is one way that first rule can get used in working with right triangles inscribed in a circle. Okay, here's the other rule that we looked at. If you have a quadrilateral, so a four-sided shape, if you have a four-sided shape inscribed in a circle, remember we know that opposite angles are supplementary. So 110 plus 2x adds to 180. I could have also said that 75 plus 3x equals 180. Right, so that would have also been true, but I only need one equation to solve for x. Okay, so let's just use the first one that we wrote. Subtract 110, and you get 2x is 70. Divide by 2, and we know that x is 35. Okay, so we need to come up with angle R. Now that we know that x is 35, we'll look at angle R. Angle R would then be 3 times 35. So if we did 3 times 35, we know this is 105 degrees, which makes sense because if that one's 70, this one has to be 105, right? Because they have to add to 180. So the other approach we could have taken for angle R would have simply been to say 180 minus 75 is 105. So we could have done that as well. We could do the same thing for this, right? Two different ways you could approach this guy. So if we just want to know the measure of angle S, well, I could do 110 plus whatever is 180. So automatically that tells me this is 70. However, we can also look at this. If x is 35, what's 2 times 35? Also 70. So there's really a couple different ways you could have come up with those angles. Also solving for x in case they said solve for x. All right, here's your last one. Real similar if you want to give this one a try. Let's just look at these guys first. Opposite angles we know add to 180 in this scenario. So I know that 3y minus 7 plus 3y plus 1 equals 180. So there's the setup. Use some basic algebra to solve it. Combine like terms. 6y minus 6. Add that 6 over. And divide by 6. No idea what 186 divided by 6 is. Yes, I do. It would be 31. Alright, so we know y is 31. Guys, keep in mind that's not what they were asking for. They want the measure of angle x. So now that I know that y is 31, let's plug it in right there. So I need to do 3 times 31 minus 7. So 93 minus 7 would give you 86. All right, let's look at the last piece. So as we look at these two, again, opposite angles of a quadrilateral inscribed in a circle are supplementary. So that means x plus 18 plus 2x equals 180. So 3x plus 18 subtract that 18 from both sides and divide both sides by 3. Not sure what that one is though. 162 divided by 3. 54. Alright guys, again, not done because you need to solve for angle W. So angle W is x plus 18. So if we did 54, let me bring that down. So if we did 54 plus 18, that gives us the measure of angle W. Alright guys, that is it for section 10.4.